Today, I'll be explaining the data visualization stage, which is an important step in any data analysis project. The goal of this stage is to take the numbers and information we've collected and turn them into charts and graphs so that we can make sense of the data easily. There are three main purposes of the data visualization stage, and I'll explain them using different types of charts and graphs. 1. Detecting missing values, inconsistent data entries, and outliers. One of the first things we need to do when visualizing data is to make sure there are no errors in it. Before diving into how we visualize these errors, let's first understand what each of these terms means. Missing values, these occur when information is absent in the dataset. For example, if we're collecting students' test scores, and one student's score is blank, that's a missing value. It's important to detect these because we need complete data to perform an accurate analysis. Inconsistent data entries, these happen when data doesn't follow a consistent pattern or format. For instance, if we're recording ages and most entries are whole numbers like 15, 16, or 17, but one entry is listed as 16 in text form, that's an inconsistent data entry. It can lead to issues when trying to analyze the data. Outliers, these are unusual values that are much higher or lower than the rest of the data. For example, if most students score between 50 and 80 on a test, but one student scores 5 or 100, those would be considered outliers. Outliers can indicate errors or unique cases that need closer examination. It's important to note that while we identify these issues during the data visualization stage, the actual corrections will happen later in the data preparation stage. Visualization helps us spot these issues so we know what needs to be fixed. Now let's look at how we can use different charts to detect these problems. Histograms are great for spotting gaps or spikes in simple datasets like students' test scores. For example, if some student scores are missing, the histogram will show gaps or empty spaces where the data is missing. This helps us quickly spot the problem and figure out which data points need attention. Box plots are perfect for finding outliers. For example, if we have a data set of weekly hours spent on homework, and most students spend between 5 and 10 hours per week, but one student reports 50 hours, a box plot will highlight that outlier. This unusual value could be a data entry mistake or a case that requires further investigation. Bar charts can help identify inconsistent data entries or missing values. For example, if we're comparing how many books different students have read, and one bar is much shorter or missing altogether, it could mean we have incomplete data for that student. Bar charts make it easy to spot these kinds of discrepancies when dealing with categories like students or products. By using these charts, we can quickly find where something's wrong in the data and make sure it gets fixed in the next stage, the data preparation stage. 2. Understanding patterns and trends. The second purpose of data visualization is to help us see patterns and trends in the data. This is especially important when looking at changes over time or differences between groups. Here, visualization helps us understand the overall story the data is telling. Instead of just looking at raw numbers, we can start to see whether certain behaviors or patterns repeat themselves, helping us form hypotheses or explore deeper. Line charts are excellent for tracking trends over time. For example, if we have a dataset showing daily temperatures over a month, a line chart will show whether the temperature is rising or falling over time. This can help us understand weather patterns, like whether it's getting hotter or colder as the month progresses. Histograms can show us patterns in simple datasets, like how many people spend a certain amount of money per week on groceries. A histogram will tell us how often people spend less than $20, between $20 and $50, and so on. This helps us see the most common spending ranges and understand how much people typically spend. Bar charts help us compare different groups. For example, if we want to compare how many books students from different grades have read, a bar chart can easily show which grade reads more. This comparison helps us see differences between categories like grades, age groups, or product types. These charts help us understand what's happening in the data over time or between different categories, giving us insight into the overall situation. 3. Correlation between variables. Lastly, data visualization helps us understand relationships between different variables, in other words, how two or more things are connected. This is essential for uncovering hidden insights in the data. Scatter plots are perfect for showing correlations between two variables. For example, if we have a dataset showing hours spent studying and test scores, a scatter plot will show if there's a relationship between the two. Each dot on the scatter plot represents a student, and by looking at the pattern of dots, we can see whether studying more is linked to higher test scores. A correlation matrix is like a table that shows how strongly different variables are related to each other. For example, if we have a dataset with student study hours, test scores, and amount of sleep, a correlation matrix helps us see whether study hours are more closely related to test scores than sleep is. This gives us a clear view of which factors might influence each other the most. Heat maps are similar to correlation matrices, but they use colors to show the strength of relationships between variables. The stronger the relationship, the more intense the color will be, making it easy to spot important connections at a glance. For example, a heat map could show us that study hours and test scores are strongly related, while sleep and test scores have a weaker relationship. These types of charts help us figure out how different factors influence each other, which can guide us in making better decisions. For instance, if we find that more study hours lead to higher test scores, we can recommend students increase their study time to improve performance. Conclusion. To sum up, the data visualization stage is about turning numbers into pictures to help us understand the data. It has three main purposes: detecting missing values, inconsistencies, and outliers using histograms, box plots, and bar charts. Understanding patterns and trends with line charts, histograms, and bar charts. Seeing relationships between variables using scatter plots, correlation matrices, and heat maps. By using these charts and graphs, we can better understand the story the data is telling us and use this knowledge to make smarter decisions, like identifying how study habits impact test scores or seeing how students' performance changes over time.